Hello, everybody. Here again for our last notes. I'm Mr. Keeney. This is Algebra Geometry 2. I say last notes of Unit 2. We are using theorems, postulates, definitions to prove and apply theorems about angles. So this is going to be theorems about angles. We're going to be solving algebraic equations. We're going to be proving some special properties of angles. And we're going to be working with the ideas of what you can see down here: adjacent, linear pairs, complementary, supplementary, etc. So let's go ahead and jump in. If we're talking about theorems of angles, we're going to come in with one that I bet makes a lot of sense in your guys' head because it talks about right angles, which you've learned a lot about from the beginning of your math journey, even before you got to high school. So all right angles, when we think about this, all right angles are 90 degrees, but that's not what they're going for here. If they're all 90 degrees, so like if this one's 90 degrees, and that one's going to be 90 degrees, and I could draw another one for you, it's also going to be 90 degrees. All right angles, if they're all 90 degrees, they're all the same, they are all congruent. So the right angle congruence theorem just says any right angle ever is going to be congruent to any other right angle. So all right angles are congruent because they have to be the same in order for them to be a right angle. So kind of a nice easy one to start off with. Our next theorem about angles, a linear pair postulate. Now a linear pair, and you can see the example down here, it's these two angles that form that linear relationship, a pair of angles that make, sometimes I say, a straight line. Now when they make that straight line, we know that they are supplementary. So linear pair, two angles that are supplementary. And if they're supplementary, then we know that the measure of angle 1 plus the measure of angle 2, those two angles added up together, what it means to be supplementary is they have to equal 180 degrees. So some things we might have known already, but now we just got a name for it. So that's linear pair postulate. Another one that we probably know maybe a little bit already is vertical angles congruence theorem. I'm not going to go too much here into it because it says right in the title, vertical angles, they are congruent. So when I'm looking at this picture, 2 and 4, I can say that angle 2 is congruent to angle 4 because they are congruent. They are vertical angles. And then also with 1 and 3, I'm going to give them two arcs. Angle 1 is congruent to angle 3. They're vertical angles. So we know that they will have the same measure, equal measure, and we can do some things with it. Speaking of doing some things with it, let's go ahead and jump into our examples. It says that the measure of angle 1 is 112 degrees. I'm going to go ahead and put that on my picture. Find the measure of angle 2, 3, and 4. Well, we just talked about vertical angles, so if the measure of angle 1 is 112, well, I know the measure of angle 3 is 112 degrees because they are congruent. They are vertical angles. And working with a different color here, I know that, I don't know what they are just yet, but I know that 2 and 4 are going to be the same. And if I remember linear pairs, so like, let me see if I can get angle 1 and angle 2, they're a linear pair, so what I'm going to do is say 180 minus 112, and if we do that, we get 68. So we have 68 degrees, which makes this one be 68 degrees as well. So, and if you add up all four of these angles, you'll get 360 because a full rotation is 360. Okay, now we're going to use a little bit more in-depth algebra. You'll notice with these, and I can get a different color here, the x's are like this, the y's are like this, and so when we're dealing with these variables, they are in a linear pair relationship. So for red here, I'm going to do 5x minus 5 plus 7x plus 5. If I add the two x angles together, they will equal 180 degrees. Same thing with the green angles. Excuse me, I can't talk right now. 6y minus 10 plus 3y plus 10. That will also equal 180. So I'm going to go through and solve these both, and that's how I'm going to get my values for x and for y. First thing I see up here is when I'm combining like terms, those will cancel out. So I get 12x because 5 plus 7 is 12 equals 180. And then I'm going to divide by 12 on both sides and get x equals, I'm going to get my calculator and do 180 divided by 12. I get x is equal to 15. And then for y, again, kind of nice here, those are canceling out. The 3 and the 6 make 9y equals 180. I'm pretty sure I know what this is, but I'll use my calculator just to not make a silly mistake. and when I divide by 9, I get y equals 20. So, boom, there we go. Linear pair relationship. And the last one here, these two angles, it's kind of a weird picture, but this angle is right here, this one is right here, and I kind of marked it with the arcs. They're vertical angles, they are equal. So I'm going to say 9x minus 13 equals 8x plus 4. And then working to solve this, I'll take away 8x first to get x minus 13 equals 4. I'll add 13 to both sides. We have x equals 17. Boom. Vertical angles. So we're coming down to our last example, which is a proof. So this proof says given that JK and this, let me see if I can highlight it for you. This means perpendicular, and we're going to talk about that. Given that those lines are perpendicular, which I've marked it over here, perpendicular means they intersect to form a right angle. So you can bet that's going to show up in our proof. We're going to try to prove that angle K is congruent to angle L, which should make sense because if you look over here, they both are right angles, and we just learned that right angles are congruent. So statement number 1 just brings in that given information. Remember, always be given. And then it says angle K is a right angle and angle L is a right angle. Well, we know this because this means perpendicular. And what it means to be perpendicular is to intersect to form a right angle. So I'm going to say definition of, and I'm going to put perpendicular like this to save my time. And if these two angles, if angle K and angle L is a right angle, well, we learned that, well, they're going to be congruent. Why? Because all right angles are congruent. All right, and that actually finishes it up. So there's your notes again, and as always, if you have questions, please reach out and I will help you out. And with that being said, congrats on getting through the Unit 2 notes. I will talk to you guys.